Alright, so this is our first video of linear programming. We are first going to practice graphing lines because linear programming we graph a lot of lines. So our first one is y equals 6. So when we are graphing y equals 6, we go to 6 on the y-axis, and then every value where y is 6. So x value could be anything. So that is going to be a horizontal line at on the y-axis of y is 6. So when it says x equals 4, you're going to go on the x-axis and go to 4, and then another point where x is 4. You can find another point. So it's going to be a vertical line where all the x's are 4. So just a reminder of what, when y and x equal a number, it's going to be a horizontal or vertical line. But we're going to get a lot of these equations, okay? And the easiest way to make this is finding your x and y intercepts, where if I do my x-intercept, that is where y is 0. So I'm going to plug 2x plus 3 times 0 equals 6. So this is 0. So 2x equals 6. So x equals 3. So that is my x-intercept. So my x is 3, and I plugged in a 0 for my y. So now I'm going to put a 0 in for my x. So this is 0. So 3y equals 6. I divide by 3. And I get 2. So 0 for my x, 2 for my y. So there's my y-intercept and my x-intercept. And if I have 2 points, I can draw the line through it. Okay? Now, I want you to pause this video and graph these two, just like how I did the other one. Okay, so the first one, I put in a 0 for y, 0 for x, and solved, so I get 7 and 7. So I graphed those and drew my line. This one, I put in a 0 for each x and y, and got 5 and negative 2.5. You might get some decimals, especially when we're working with the story problems like we will, and that is okay. We can graph decimals, not a big deal. Okay? So that is graphing lines. Now, these are what we are going to be graphing for our linear programming, is graphing inequalities. Okay? So, what I want you to do is we are going to pretend like they're equal signs when we graph. Then we are going to pick a point and see which way we need to shade. So, we are first just going to graph given the constraints. So let's do our x and y axes here. Which, if x equals 0, so x is 0 right here, x is still 0 here. So this line is x equals 0. And then this one, our y is still 0, our y is still 0. So y, I should do greater than or equal to 0, greater than or equal to 0. Okay? Now, if I pick a point, let's say this point 1, 1. Is 1 greater than 0? Yes. So, to make your life easier, This is going to be my green line, and I am going to shade everything over here, because this is x is greater than 0, x is greater than 0, all of these are. Okay? And I just shade it lightly. Now, this is going to be my red line. And just like our every point above here is greater than 0, so I'm going to shade above my axis line, above that graph. Okay, so now right now anything in this square is shaded twice. Okay, so now in order to graph this one, I need to find your x and y intercepts. So 0 minus 3y equals negative 12, negative 3y equals negative 12, divide by negative 3, so y equals 4. Then x minus 3 times 0 equals negative 12, so x equals negative 12. Okay. Uh-oh. I didn't do that. Let's make this a positive 12. And a positive 3. Sorry, guys. So this is a positive 4 and a positive 12, only because my graph doesn't go negative. Okay, so y is 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to go by 2's. So let's go by 2's here too. 2, 4, 6, 8, 10, 12, 14, 16, 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so now I need to go x right there, so 4 and 12. So now if I put in a 0, 0, is 0, 0 greater than or equal to 12? Okay, let me show you again. Sorry, I'm needing to show that. So if I plug in the 0, 0 point, remember you can pick any point, just not on that line, you can pick any point, but zeros are the easiest. 0 plus 3 times 0, is that greater than 12? False. Okay, so that means this is my feasible region up here. So I'm going to make a 2 right there. So now 3 times 0 plus 2y equals 24. So 2y equals 24, y equals 12. 3x plus 2 times 0 equals 24. 3x equals 24. X equals 8. So here's my orange. So x is 8, y is 12, and then I plug in a test point. So 3 times 0 plus 2 times 0 equals 24. less than or equal to. So is 0 less than or equal to 24? Oh, you can't see that. So I plugged in 0, 0. That does work. So that means my shading is going to be this direction. So the reason why we shade is to show the feasible region. So here's one point. So this is my feasible region. Okay? So again, let's go back from the beginning. Here's my constraints. I first need to graph those lines. So this right here is just finding your x and y intercepts. Okay? When you are given absolute value, I pick a test point. I try to pick 0, 0. I couldn't pick 0, 0 because 0 was on the line. You have to pick a point that's not on the line. So then, if you see here, I picked this point. It did not work for this graph, the blue one, so I had to go above. And it did work for the orange one, so I went below. So that means that this right here is my feasible region. Okay? And we will talk about finding the vertices and all of that later to find the cost equation. But right now, just graphing the lines. Okay? So here's another one. Let's see if you can graph the constraint and just find the feasible region. So here is your constraints. Pause the video and at least start. And then okay, I just wanted to show my first two lines. My x is greater than 0, my y is greater than 0. So here are my two lines. Those ones should be pretty easy. The x is greater than 0 is everything. This is green over here. Blue, everything up here. And now I have my three other ones. Okay? Remember, you're graphing the equation and then picking a test point to see which one you shade. So first let's graph the lines. And then, so pause the video, graph those three lines, and then we'll walk through a test point if you're still stuck on it. Okay, so I just lightly colored what color I was working on so I can keep track of all of my work. So my red, well, first I did my orange, which is right here, my vertical line of x equals 9. Then I did my red. I graphed my two intercepts and drew a line, making sure that you did x is 20 and y is 10, just making sure that you are putting in on the right axes. That's easy to miss sometimes. And then I did 11 and 15 for my purple. Okay? Now it doesn't matter what color you make them, but color coding things is very helpful. So now let's look at the orange, and x is less than 9. So I need to color in everything less than 9. Well, less than 9 is going to be in this region here, between 0 and 9. Okay. Then my red, 0, 0. If I plug in 0, 0, and I can do that, 0 plus 2 times 0 is less than or equal to 20. So is 0 less than or equal to 20? Yes. So that means 0, 0 is part of my region. So that is this region right here. Then my purple. So if I look at 15 times 0 plus 11 times 0 is less than or equal to 165. 0 is less than or equal to 165. And that does work again. So that is 0, 0 is part of my region. So I need to go this direction. So now my feasible region is where they're all shaded. So that means that my feasible region has these vertices those 5, and it's everything in between here. Okay? So, now I'm going to do this one step further on the next video, but just graphing and figuring out your feasible region is our first step of our linear programming. So there is a worksheet to complete after this.